to the White Cliffs of Dover to join Howard Stableford for a special edition of Tomorrow's World.
You're looking down on the construction site of the Channel Tunnel at the base of the Shakespeare Cliffs just outside Dover. Underneath me are the tunnels themselves, now stretching out some 17 kilometres over 10 miles under the sea, halfway towards France. By 1993, the link should be completed and trains speeding their way between Britain and Europe. And later on this year, the first tunnels are due to join up, and so tonight, Tomorrow's World is taking a very close look at the largest engineering project in Europe.
And welcome to the control centre for the British tunnelling operation. And in fact, we're just at the edge of the cliff where Howard is standing at the moment. Despite arguments over costs between the operators Eurotunnel and the construction consortium TML, this massive project is going ahead faster than ever. In fact, the British and French tunnels are approaching each other at over 400 metres a week. Tonight, we'll be joining Peter live at one of the cutting faces, 4 kilometres out under the channel. Kate explores a section of completed tunnel starting from the cliff top. Howard takes a car driver's view of a journey through the tunnel and reports on precautions to make sure it's safe. And from the French network, Antenne 2, Isabelle Stays joins us to explain how animals and rabies will be kept out of the tunnel. She also reports on construction at the French end of the project. But first, the project itself, a link from England to France that will graft together the rail and road networks of Britain and continental Europe, making it possible to take a train direct from Glasgow, say, to Paris and even Vienna. Passenger trains will share the tunnel with shuttle trains for cars and lorries, operating between terminal sites a few miles inland. And between them run not one, but 3 tunnels. The 2 outer running tunnels carry the trains, while the smaller service tunnel in between will allow access for maintenance and emergencies. The British tunnels are all being cut from a construction site here at Shakespeare Cliff, with 3 tunnels going towards France and 3 going inland to the terminal here at Cheriton. And again, over here from the coast at Saint-Gat, 3 tunnels head inland to the French terminal and 3 out to sea. And the lights here show you how far they've got. You can see the scale of the operation from the air. At the foot of the Downs, this is the terminal site of the British side, covering 350 acres. And it's here the trains will first go underground. Then 5 miles away, the Shakespeare Cliff site, where we are now on the cliff top. And just outside the control room here is Kate by the main access shaft.
Yes, Judith, I've been through the standard safety procedures before I'm allowed to go down. I've been given 2 numbered tags, and I've got to leave one of them at the entrance to any tunnel I go into, so as they know where I am. And I've also got my emergency breathing kit. Now, this hoist is going to take us down 110 metres inside the cliff, down to where all the action is. And this is the main access shaft for the 500 or so workers who are down underground at any one time.
And we can follow all of Kate's movements on a model here. Now, this is really all cliff top, but it's been cut away so that you can see the intricate arrangement of tunnels underneath. Now, we're on the top just here, and this is the shaft where Kate is going down. And at the bottom, the 3 tunnels. France in that direction, inland to the Cheriton terminal this way. And over here, the lower works sites that you saw at the start of the programme. And there are 2 shafts connecting that site to the tunnelling operation, carrying materials down and spoil back. And when Kate reaches the bottom of the access shaft, she'll emerge into this section that links all 3 tunnels together. And that's where all the tunnelling began, just over 2 years ago.
Well, we're now down at the tunnel level, and you can see just how far we've come if you look back up the shaft up there. Now, this is where it all started. That side goes towards France, and this side goes towards the English terminal site at Cheriton. Now, the first tunnel we come across is the Northern Running Tunnel, and going out here is towards France. Now, the whole of this area is a sort of marshalling area for all the construction trains. And the next tunnel we come to is the Central Tunnel, the Service Tunnel. Now, on one side, it goes up to the terminal site at Cheriton again, and down this way, this is the Service Tunnel going out towards France. Now, the final tunnel is the Southern Running Tunnel. And I think you're actually going to be able to see this one going out to the terminal. Yes, that's the side that goes out to the terminal at Cheriton. Now, in front of me here is the bottom of that sloping shaft that brings all the materials down from the lower construction site at the foot of the cliff. But this is the Southern Running Tunnel out towards France, and it's the far end of here that Peter is at the TBM, about 4 kilometres away. Now, I'm going to go out a bit further down here, and there's a train waiting to take me further down into the tunnel now.
And of course, everything that's happening here is also going on at the French side of the channel. From here at Shakespeare Cliff, it's just 23 miles to the coast of France. From there, we asked reporter Isabelle Stays to guide us round her end of this Anglo-French project.
Here in Sangatte, there may not be high cliffs to cope with, but the geology of this coast presented its own problem: groundwater.
During the last tunnel project in the 70s, this shaft was started, gently sloping down under the channel.
But constant flooding eventually proved too much and was one of the reasons for abandoning the whole scheme. So this time, the engineers took a different approach.
This massive vertical shaft was cut 45 meters down to the tunneling level and lined to keep all the water out.
So, unlike the British end, everyone and everything come and go through this one route.
From concrete tunnel linings going down
to the spoil which is pumped up through those pipes.
The base of this shaft has become a large underground construction site, serving all the tunnels. The loading and unloading of all the trains in this area requires a complex railway network, which is directed from a control room at the top of the shaft. It also acts as a communication center and a monitoring point for conditions throughout the tunnels.
But whichever end of the tunnel you look at, French or British, all the activity is aimed at one thing: serving the giant tunnel boring machines.
Well, those specially designed tunnel boring machines, or TBMs for short, are enormous. They're like gigantic mechanical earthworms, 250 meters long. They're really moving factories, inching their way along as the tunnel is dug out. And there's one of these at every cutting face. Well, running through the machine, there's a conveyor belt which is continually taking spoil away from the cutting face, whilst concrete segments are moving the other way, ready to line the newly cut tunnel. Right at the front is the front shield. That's the cutting edge with rows of tungsten carbide teeth which rotate. That's actually one of them, grinding up the chalk. And when 1.5 feet have been ground away, then it stops. It builds a complete circle of concrete segments. Then the whole thing jacks forward before starting to grind away again. Well, the TBM is controlled by a control room, which is back here. And on the machine that's cutting the Southern Marine Running Tunnel, we should find Peter live at this moment on a platform down here.
Well, yes, indeed, here I am. And the atmosphere down here is quite incredible. It's swelteringly hot, it's very humid and also very noisy. But they're making very good progress. To give you an example, this spot I'm standing on at noon today was solid rock. Now the cutting face is just 15 meters beyond this section here. And the guys down here are laying yet another segment in the tunnel wall. But to reach this point turned out to be quite a journey in itself, as I found out earlier today. It's taken me 20 minutes to get here. 4 kilometers back in that direction is Shakespeare Cliff. But right up ahead of me, all that is filling the tunnel is the tail end of the tunnel boring machine. As you walk along the machine, you really begin to understand its description as a factory for making tunnels. Everything from a workshop for quick spare parts to a mess for brewing a quick cup of tea is dragged along inside. And this is the tunnel's guidance system. A laser bolted to the side of the tunnel sends its beam through a series of control targets until it reaches a light-sensitive target right up at the front of the tunnel boring machine. Well, back here live at the cutting face, that light-sensitive target is right up there, and the information from that is sent through a computer to the control cabin here, where the controller, who is Paul here, can be told then exactly what direction he should send the cutting head, whether it's too far to the left, too far to the right, up or down. Now, they're actually working the whole tunnel to a tolerance of just 60 millimeters. Now, Paul, that's incredibly precise. How do you keep such exact control over the cutting head?
Well, we steer the machine using a joystick here, which we can move in any direction. And this in turn, for instance, if we put it to the right and up, as you can see, it sends the information down to the head, which automatically steers the head from there.
Are we actually cutting at the moment?
No, but we're just about to start now.
Right. Okay, we hope that we've got a camera right there at the cutting face. Hopefully, giving us pictures of the teeth actually clawing their way into the rock. At the moment, we can see it now. There it is, the teeth clawing away at the rock there, and we have the spoil pouring out on the other monitor back to the trains to take it back out. But now, over to Judith again.
Quite amazing. We'll be going back to Peter later. So what's it going to be like to use this tunnel once it is open? Well, Howard's leapt forward to 1993 to find out.
Just take those old records off the shelf. I said listen to them by myself. Today's music ain't got the same soul.
Well, here I am travelling along the southbound carriageway of the M20 just outside Folkestone, and by using the Channel Tunnel I'm less than 3 hours away from strolling down the Champs-Élysées or from sitting outside a chic cafe on the Boulevard Saint-Michel. And this is the first stop, the UK terminal for the shuttle service to France. Motor vehicles only, carried on special trains 800 metres long, with a locomotive at each end. And you simply drive straight on. For lorries and buses, there'll be a single deck, but for cars, there's an upstairs and downstairs. Then, when the train's full, special safety doors close to separate each carriage. These stay shut the entire journey as part of the fire precautions. But you can get through either side if you need to evacuate the carriage in the event of an emergency. And after that, we're off. During the crossing, attendants patrol the train. They're making sure, for instance, that if you do leave your car for any reason, say to go to the loo, that you get back in it afterwards. They also check that you're not smoking, that your ignition is off, and that you leave a window open. That's both for ventilation and to hear the announcements on the tannoy. The journey takes 35 minutes, just enough time for a little conversion job. Not bad. Oh, nearly forgot. So that's it, and because all the formalities like paying and customs are taken care of before you leave, getting off at the other side is a breeze. And if everything goes according to plan, the total journey time is 75 minutes from English motorway to French autoroute. Right, well, I'm on my way to Gay Paris.
Unfortunately, that's 3 years away. But let's go back live to the tunnels, where Kate, on her rather less comfortable train, has travelled about 300 metres into a section of the completed tunnel.
Yes, and I'm now in a completed section of running tunnel. Now, the passenger trains that will be coming through this actual tunnel will be coming from France to England, zooming through at about 160 kilometres an hour. Now, this tunnel is 7.6 metres in diameter. That's big enough not just for those passenger trains, but also for the larger shuttle trains, which will be carrying all the vehicles. But the only trains that are coming through here at the moment are the works trains, like the one I came here on. And they use these two tracks and also the overhead cables. But eventually all that will disappear and a single standard gauge track will be laid. Now, those shuttle trains are actually travelling slower than the passenger trains, but they practically fill the whole tunnel. And that means that there's going to be a build-up of pressure in front of them as they push along the air. And to relieve that draft, the air will be able to escape through piston relief ducts, like this one up here. They're about every 250 metres, and you can see this one cut into the side of the tunnel here.
The piston ducts connect the two running tunnels together. When a train comes through, some of the air is channeled into the other tunnel, relieving the pressure. Now, another problem is getting fresh air in, and the main ventilation route for that fresh air is through the central service tunnel. From there, it feeds into the running tunnels through these connecting cross passages. And there are doors which seal the service tunnel from the draft of the trains. But louvers in the doors allow fresh air to filter through. So in any emergency, passengers down in the central area will get fresh air.
And the air quality throughout the tunnel and the temperatures will be monitored just as they are now during construction here in the control centre. Well, this, for instance, is a map of the 3 tunnels, and Kate is about here where that cross passage is. Now, these symbols you can see are a series of sensors, and from them I can tell, for instance, the temperature down there is 20.4 degrees Celsius, and the carbon monoxide content of the air is 7.9 parts per million. So that is, in fact, well below the safety level. It should be very good, clean air to breathe. And Kate's down there having to do all the breathing. So, Kate, how's it?
Well, it's good to know that I'm breathing fresh air down here. Now, these tunnels aren't actually straight. If you look down there, you can see the bend. If you follow the line of the lights, you can see where they curve round. That's the bend. Now, the reason for that is quite simple. Geology. Now, there's a type of chalk down here called chalk marl, which is, it's a bit like clay, and it's impermeable to water, but it's relatively soft. So that makes it by far the best thing to tunnel through.
A layer of chalk marl is not at a constant depth under the channel, as you can see on this model, this dark grey area here, with the red tunnel snaking its way through. Now, at this end, the marl actually drops away. So the French were forced into the much wetter white chalk, which influenced the way the spoil was removed. With more water added, it's piped as a liquid into a specially prepared nearby pit. The chalk settles out, and eventually the whole area will be landscaped. Back on the British side, dumping the spoil into a large pit was environmentally unacceptable. Instead, the solution was to construct a large lagoon at the base of Shakespeare Cliff, which could be filled with chalk to form a platform of reclaimed land. The spoil emerges from the tunnels on conveyor belts and is then carried by trucks to the lagoon. When the project's ready, most of this reclaimed land will be converted into a public park and a nature reserve. But at the moment, this lower site is used to assemble and prepare building materials, like the concrete segments used to line the tunnel.
The special concrete mix for these segments is designed to last 125 years and limit the corrosion of the steel reinforcements. The designers say that it's strong enough to withstand the pressure from outside and also to survive any accident or explosion within the tunnel.
And of course, safety in the tunnels has become the subject of heated debate. Not just the integrity of the structure, but also protection against fire. This is the final design for the shuttle trains, and most of the attention has been focused on them and the protection in emergency for the passengers who'll be riding inside them with their vehicles. Howard's been looking at the measures proposed, starting with the research centre in France, where they've been developing one of the first lines of defence against fire.
This time it's just a mock-up, and this is only water. But fire on an 800-metre long train is, and always has been, a major concern of the designers. And that's the reason for these, the stainless steel doors that you saw earlier. They will contain a fire for 30 minutes, and that time is crucial because at normal speeds it's long enough to get the train out of the tunnel. That way, all the time that the fire is being fought through there, we're speeding towards daylight and help. Eurotunnel have convinced the Channel Tunnel Safety Authority that not separating passengers from their cars will be an advantage. They say a fire, perhaps in the engine, will be spotted and tackled quickly with portable extinguishers. But it won't just be people on the lookout for trouble. Around each carriage, they plan a mass of electronic detectors, ones for heat, smoke, flame, and the vapour from petrol spills. But when a problem has been spotted, what happens next? Here at Serchard, the French National Centre for Safety Studies, tests have been conducted to decide just that. Well, this is an exact replica of the size and layout of one of the single-decked shuttle wagons. And as you can see through here, they've even put a coach in it. Every detail of a real fire can be modelled in here. They can even alter the air pressure at either end to recreate the effect of speeding through a tunnel. And the doors can be automatically opened and closed to simulate an evacuation. They've decided on 3 basic levels of defence. Now, the first one we mentioned earlier is this. Well, that's fine for putting out a fire on a seat, but what about something bigger? If this were petrol, it could develop into a substantial fire in seconds. Into the floor of each carriage, beneath these metal grills, the designers have built in 5 flat trays. And then all along the sides of the trays and also on the walls, there'll be rows of nozzles to spread foam directly onto a fuel spill. Each carriage will carry about 200 litres of foam, which is enough for a minute's worth of spraying. It doesn't sound much, but in the tests they've run here, they've been extinguishing fires in about 6 seconds. The final defence, designed as a last resort, is this, Halon 1301, and it's dispersed from nozzles inside the carriage. And because it's a gas, it can penetrate anywhere throughout the carriage, and so can deal with fires inside the vehicles as well as outside. It works, even at quite low concentrations, around 6%, by interfering with the combustion process. However, critics point out that higher concentrations could be dangerous or even fatal. But the designers say it would never reach those levels, and in any case it wouldn't be used until everyone had been evacuated from the carriage. After nearly 3 years of tests, TML and Eurotunnel are confident that their system will be safe. But an Anglo-French safety authority will first of all have to approve their plans, and only then can the final design work and the massive task of constructing the shuttle wagons begin.
The tunnels themselves will also be regularly patrolled for safety and security checks. And outside, around the terminal sites, there'll be high security fencing. And that's not just to keep out people, but also animals, another matter of public concern. Isabel Stays reports.
Rabies has not been found in Britain since the 1920s, but here in mainland Europe it has been around for centuries. But don't worry, Ziggy here is quite safe.
Vaccination of anyone thought to be at risk has meant that no one has died of rabies in France since 1924. But recent reports suggest that the disease is spreading and it's vital it doesn't reach Britain. That means stopping foxes, the main carriers, from getting through the tunnel. Here, at the Rabies Research Center near Nancy, they've built a model of a small section of tunnel where they could try out different types of barriers.
This is what they came up with, this electrified grid. It works on the principle of an electric cattle fence. It gives a shock, which is not enough to seriously hurt an animal, but enough to warn it off.
The tests involve taking a wild fox that has been caught by local hunters and putting it in the mock-up for 5 days. They put its food at one end and its box at the other. Then, when the fox is used to the grid, they turn it on. And for 7 more days, they watch to see what happens. So far, they have tested several different foxes, including one that actually had rabies. With the grid switched off, the foxes crossed thousands of times in the 5 days. But with the grid switched on, only one fox crossed, and it was not the rabid one.
Even though the grid is not a complete barrier, it is a very effective deterrent, and for the experts working here, that's enough. They say that bearing in mind the security fencing around the entrances and the hostility of the tunnel environment, the chances of an infected fox getting to England through the tunnel are negligible and certainly no higher than those of a fox stowing away in a ferry.
Now we're going back to Peter at the TBM.
Well, since we came on the air, yet another segment has been completed, and any second now we're expecting the tunnel boring machine, or 250, there it is, 250 meters of it, to be jacked slowly forward. You can see it moving beside me here. Last week, it moved forward 260 meters, and there's only another 28 kilometers still to go. Now, you may be wondering what happens to the tunnel boring head. I better step back. If and when it reaches the French side, well, it'll be too large to back out because with the lining, the tunnel will be smaller than the head. So it'll do a dramatic right turn, bury itself into the rock, there to be left forever.
The running tunnels aren't due to meet up until sometime next year, but the smaller service tunnel now has just 11 kilometres to go, and it's due to link up at the end of this year. That may trigger a real conviction across Britain and Europe that this time, after all those false starts, the Channel Tunnel is really going to happen.
And Tomorrow's World will be reporting on that momentous occasion, and we'll also be keeping you up to date with the huge challenge of installing the train systems and the terminal sites. Well, that's all from us at Shakespeare Cliffs. Our enormous thanks to all the staff here who've been tremendous help. Next week, we're back to normal, live in the studio. Do join us for that. Till then, good night.